This material is out of a sci-fi film. This is transparent aluminum. If you are a Star Trek fan, then you should be fully aware of this material.
Transparent aluminum?
However, if you aren't a Trekkie, perhaps you have never heard of this material. This is Materials Lab, and today we will discuss transparent aluminum. This material is not a metal, but a ceramic called aluminum oxynitride, which is composed of equal parts aluminum, oxygen, and nitrogen. It is known by scientists as Alon.
What we do is turn the powder into a solid, transparent shape that looks like glass.
Alon is aluminum, oxygen, and nitrogen, and when you put them together in the right proportions, you get this transparent ceramic, says Dr. Lee Goldman. Alon was first investigated during the 1960s and 1970s. That may be surprising, that it's been around for such a long time. Even more surprising is that it has many uses. But where is such magical material used? The toughness of transparent aluminum makes it a great choice for infrared windows. It is also used for making armored windows and optical lenses. It is immensely tough. A laminated pane of Alon 1.6 inch thick can stop a .50 caliber rifle round. The most bizarre use is in the use of heat-seeking missiles. Most glass absorbs infrared light, but Alon is essentially transparent and lets the light pass through with no issue. This means that guidance instruments inside the missile can see through the Alon dome, while its hardness prevents scratches and cracks as the missile fires. As space tourism continues to rise and the possibility of flying in space becomes a reality, materials are needed that can take the brunt of the damage. Moving at thousands of miles an hour, micrometeorites and debris carry far more energy than bullets. These are regarded as hypervelocity impacts, and scientists believe that with Alon's physical properties, it would be able to withstand the conditions associated with the multiple launches and re-entries a space shuttle would make. It is difficult to produce. Aluminum oxynitride powder must be pressurized to 15,000 pounds per inch in rubber molds submerged in hydraulic fluid. Along with being difficult to produce is that when you figure out how to produce it, it also needs to be pure, and producing this material is too expensive in the eyes of those who need it. They are content with paying less for glass and the plants to manufacture glass for their needs already. So, with difficulty in producing the material and the interest in building facilities that could produce the material for the needs is low, this material will continue to be created in small sizes. That is, until new methods or a company decides to heavily invest in producing the material. As more industries switch to Alon for their needs, the price of the product could drop to a point that makes it cheaper to use than other applications. Who knows? An even better material could be right around the corner.